here. Now this is an Arduino out there. Okay. And what type of board it is? Arduino Uno out there, right? The most sorted board out here. Let me just zoom in so that I can show you every single thing into this in a very clear order, and you know what are the things that you have into this Arduino Uno board, and then we'll begin with it. So let us start from the. So if you just have a look at this is a Arduino board we have here, and you can see this like it looks almost the same out there, right? What we have out here. So if I just could show you here, it just looks the same thing. So starting from here, so onto this side, you have a digital pens. And we have understood very well, like in the earlier sessions, like what is the digital and what is the analog out there. So digital pins are nothing but a discrete pins, which is going to give you either 1 or 0. So how many you have it? Starting from the 0 until 13, you have almost 0 plus 13 pins, all right, which are digital pins. And then you have 1 pin as a ground and 1 pin for a reference. And then you have a some symbols you can see here. If you just could see the symbols and this symbol, this symbol, and this symbol. And here also you have a few pins. So this means that these pins can support PWM. What is a PWM? Pulse width modulation. More about that later. Then at the last two, you also have something called TX and RX for 0 and 1. So what is this TX and RX? So TX is a transmission, RX is receiver. Okay. So the transmitter and a receiver. TX is a transmitter, RX is a receiver. The reason why we have this is because we do not have any sort of connectivity, wireless connectivity with this. Just in case, imagine that you have to go ahead and then make use of a Bluetooth module, which you want to connect with this, which also will be doing in the sessions. So if you have to do this, then how do you connect it together? So how do you get that? So you're going to make use of this RX and TX so that you can get started with them. Okay, more about that later. So once we are done with it, then we have this particular LED out here, which is saying on. So this is going to give you a indication like whether the Arduino is turned on, it has a power supply or not. So based on that, we have a power supply or not, we get to have it here. All right. Then we have if the power supply is available, this will glow in green color, and if not, no. And just in case, if you have done any short circuiting anywhere here, okay, anybody have done some short circuiting, this may turn off. Okay, so you might easily get to know like there is some issue with the connections out there. Then we have a L, which is again one more LED out here, which indicates which is a built-in LED out there. So by default, there is one LED which is built in into the Arduino itself for programming. So you can program this LED. Internally, very importantly, internally, this is also connected to pin number 13. So if you make a pin number 13 high, which in turn means that this will turn on. If you make pin number 13 low, this will turn off because this LED is connected to this. All right. So this is a built-in LED out there. We'll be seeing that in some time. Then we have a TX and RX. So what is a TX? Again, transmitter and receiver. So whenever there is a transmission or receiving happening, this TX and RX will blink. All right. I'll show you that also in some time. Let us go ahead here and see what are the different things we have into it, which we will not be using it, which will not be going through and doing any sort of manipulation to this. We're going to only use these pins and the pins on the other side, but I'm just going to tell you everything out there so that you're very confident like what exactly you have in your development board. So here we have a this is a TTL converter, which is going to convert this particular USB to this, like will help the data from coming from here to this particular microcontroller. All right, TTL converter. Okay, transistor. Then we have a 3.3 voltage regulator. This is a 3.3 voltage regulator, which will go ahead and step down the 5 volts, which is coming from this micro USB to 3.3 volts, because this IC is going to work on 3.3 volts only. And then we have, this is an oscillator, which is of 16 megahertz. Okay, frequency, this is the clock actually, which is 16 megahertz. These two are 24 volts capacitor, hopefully. No, 25 volts capacitor. So these are two 25 volts capacitor. And this is a DC jack. You can see this here. This is a DC jack, what you have here, where you can go ahead and give up to 25 volts of power supply. And this capacitors will handle that. Voltage regulators will handle that, and that should work perfectly fine. But nobody uses this actually out there, okay? doesn't really make a sense. And then coming to the other side of the board here, you have analog pins. Now, analog pins are nothing but like which can take analog data signal and also give you an analog data signal output. So how many pins we have? A0 to A5, total of 6 pins you have into it. Then we have some power pins, V in, that is if you want to give a 5 volts in, then you can give from this. Then 2 ground pins you have it. Then again 5 volts output you have it. So this will give you 5 volts output. Then 3 volts, 3.3 volts output, it is giving reset pin and IO reference pin. So these are the different pins that we have into this particular. And this is your main microcontroller, which is of 28 pins, 14 on each side. So this is a ART-Mega 328P microcontroller. So this is going to help us like do all the things we would go ahead and need to do with this. So let us go ahead and then have a look at what are the different things we have and see what can we do with this. So this ART-Mega 328P, what we have it is a very simple out here. It has a 16 megahertz clock frequency out there. So it is just a 16 megahertz clock frequency out there. And it just have a 32 kilobytes of system programmable memory, 32 kilobytes, and 1 kilobytes of EEPROM and 2 kilobytes of SRAM, that is RAM out there. So pretty simple. And all these are 8 channels ADC, that is 8 bits. Okay. And this microcontroller, what you see is also an 8-bit microcontroller. Okay. It can process only 8 bits at a time. I think so. The computers, what we have with this are 64-bit microcontroller, 64-bit microprocessors. But this is 8-bit microcontroller. And when I say 8-bit microcontroller and when I say 64-bit microprocessor, you might be like, this is very low in number, right? What can this literally do? Trust me, it can do amazing things which you cannot even think of. 8 bits can do a lot much. So this is all about what is this particular thing, what you're going to use now. And let's get going with this and start with it.